Susie and Michael are each riding bikes. Initially they are separated by 4,000 meters, and Susie is west of Michael. Susie starts riding north at a rate of 5 meters per second, and 7 minutes later Michael starts riding south at 3 meters per second. At what rate is the distance between them changing? 15 minutes after Susie starts riding. If we call this y, then the separation between them in this direction would be dy dt, and that's going to be 8, because she's going at 5, he's going at 3. So overall, the distance between them in this direction increases at 8 when they're both riding. The actual distance between them is like this. And this is the separation here that we've called y. And we know that this remains at a constant 4,000. So if we call this d, then by Pythagoras, d would be the square root of y squared plus 4,000 squared. Therefore, dd dy would be, remember this is y squared plus 4,000 squared to the half, a half of y squared plus 4,000 squared to the negative a half multiplied by 2y. These twos cancel, and that gives me y over the square root of y squared plus 4,000 squared. We want the rate of change after 15 minutes, so we need y, the separation in this direction, after 15 minutes. At this time, Susie has been riding for 15 minutes, so that's 15 times 60 seconds multiplied by her speed. So we need to do 15 times 60 times 5, so 4,500. And Michael has only been going for 8 minutes. So that's 8 times 60 times 3. So 8 times 60 times 3 gives us 1,440 meters, and that means that y is 4,500. Add the 1,440, giving us 5,940. Now we want dd dt, which is dd dy times dy dt. So dd dy is y over the square root of y squared plus 4,000 squared, and we need to multiply that by 8. We know that y is 5,940. So that's 5,940 over the square root of 5,940 squared plus 4,000 squared multiplied by 8. So we just need to calculate that. So 5,940 over the square root 5,940 squared, add 4,000 squared, and we'll multiply that by 8, and it gives us 6.64 meters per second.